There are moments in history when science hesitates, when the instruments are flawless, the equations are sound, and yet something refuses to fit. For centuries, we've trusted the sky to be predictable. Every orbit, every flash of light, every fragment of dust has a reason. We built entire civilizations on that certainty. But every so often, the universe throws something back at us, something that doesn't belong, something that moves with purpose in a place where purpose should not exist. And when it does, the question is never just what it is, but what it means for everything we thought we understood. This is one of those moments. An object has entered our solar system, small, silent, and impossibly precise. To most, it's a curiosity. To a few, it's a warning. They call it 3i Atlas, and it may be the first thing to ever make the universe look back. Chapter 1. The object that shouldn't exist. 13 days before it brushes past the face of the sun, a faint shimmer moves through the darkness between worlds. It is small, unassuming, barely large enough to cast a measurable shadow, yet its path cuts cleanly through the fabric of the solar system, a line so straight it almost looks intentional. Astronomers mark its presence in data before they ever see it. A flicker on a screen, a variation in brightness that doesn't follow the rules. In a universe built on predictability, 3i Atlas refuses to behave. It burns where it shouldn't, dims when it shouldn't, and glides with the stillness of something that does not care to explain itself. The name means little. The third interstellar object, discovered by the Atlas Survey in 2025. But names are a comfort. They imply understanding, ownership, control. And there is none of that here. From the first observation, the numbers whisper contradiction. Its velocity is interstellar, far beyond what the sun could have given it. Its trajectory lies almost perfectly within the plane of the planets, a near impossibility for a random visitor from another star. Its spin, its reflectivity, its thermal signature, each slightly wrong, each suggesting a design no natural process would bother to create. To the untrained eye, it is just another streak of light among billions. But to a mind sharpened by decades of precision, it is a message written in the language of the impossible. Sabine Hossenfelder is not the kind of scientist drawn to mysteries. She has spent her career dismantling them. A theoretical physicist known for her sharp skepticism, she made a name exposing pseudoscience, demanding rigor where others offered faith. To her, belief without evidence was a contagion, one that science existed to cure. For years, she treated every whisper of the unknown with disdain. Warp drives, quantum consciousness, alien probes. Her answers were always the same, simple, measurable, rational. But data is a ruthless teacher. And when the data stopped obeying, she did what few of her peers dared to do. She questioned herself. In early October 2025, she released a quiet statement. No grand announcement, no press conference, just a paper, calm, clinical, devastating. In it, she wrote that the observations of 3i Atlas cannot be reconciled with known cometary behavior. Then, one line that rippled through the scientific community like a shockwave. The possibility of non-natural origin cannot be excluded. She wasn't saying it is alien, she was saying it might be. And for someone like her, that single word, might, was heresy. The deeper researchers looked, the stranger 3I Atlas became. Its spectral data showed emissions of nickel and iron, metals rarely seen evaporating from natural comets. These elements require sustained internal heat, as if the object were not frozen rock, but forged alloy. The ratio of carbon dioxide to water vapor was 8:1, an inversion of the chemical balance in every known cometary body. Some called it an error in calibration. Others whispered it looked more like exhaust. The polarization of reflected sunlight didn't match dust or ice. It hinted at an unnaturally smooth surface, the kind that light glides across rather than scatters from, a surface manufactured, not weathered. And then there was the tail. Every comet's tail points away from the sun, pushed by radiation pressure and solar wind. 3I Atlas did the opposite. Its trail bent toward the sun, as though something inside it was venting deliberately against physics itself. Each anomaly could be explained away on its own. A glitch, a coincidence, a model error. But together, they painted an image too deliberate to ignore. To some, 3I Atlas is nothing more than an improbable comet. To others, it is the first artifact from beyond human reach. Its orbit, tilted only 5 degrees from the ecliptic, threads precisely through the lanes of the inner planets, past Jupiter's gravity, near Mars, grazing Venus, but never once approaching our Earth closer than safe observation distance. If you wanted to send a probe to observe without being seen, that would be the path you'd take. Statistically, such alignment should occur once in hundreds of random trajectories. Yet here it is, indifferent to probability, moving as if following instructions older than our civilization. In the old days, such a discovery would have been celebrated. Telescopes would pivot, funding would flow, and humanity would lean toward the unknown with open eyes, but not now. Now, the fear of being wrong weighs heavier than the wonder of being right. Hossenfelder called it the cost of caution, the hidden tax we pay on curiosity. She argued that science has become so terrified of false positives, so desperate to protect its reputation, that it risks missing the very truth it was built to find. We've optimized for not being wrong, she wrote, but in doing so, we've forgotten how to be brave. To her, 3I Atlas is a mirror held up to modern science. It shows how fragile certainty really is, how easily the unknown slips through the cracks of consensus. When Oumuamua passed through the solar system in 2017, most dismissed it as an oddly shaped rock. A handful, Avilob among them, suggested otherwise. He was ridiculed for calling it a possible probe, a relic of some distant civilization. 8 years later, his words no longer sound absurd. Loeb now points to 3I Atlas as vindication. He notes its non-gravitational acceleration, its timing, arriving when Earth is shielded behind the sun, its eerie steadiness, the mathematical fingerprints of intent. He calls it a quiet visitor in a loud universe. And perhaps that is what unsettles us most. The idea that silence can be intelligent. No one knows what 3I Atlas is. Maybe a fragment of an ancient star system, a frozen seed from a cosmic collision. Maybe a probe, long since dead, still following instructions from a lost origin. Or maybe it is something else entirely. A reminder that not everything crossing the void must fit our definitions. But its existence forces a reckoning. If it is natural, then nature is far stranger than we imagined. If it is artificial, then intelligence is not unique to us, and we are no longer the authors of the only story worth telling. Either way, the line between discovery and faith grows thin, and that, for the scientists watching, is the most uncomfortable truth of all. 13 days until perihelion, the moment when 3I Atlas dives closest to the sun's furnace. If it is a comet, it will fracture, vaporize, scatter into dust. If it is something else, something built, it will survive the heat, adjust, perhaps even change direction. Every observatory on Earth is waiting. Every telescope is watching. And somewhere, in a quiet office surrounded by equations, a physicist who once mocked the impossible is waiting too. Because she understands what few others dare to say aloud. If 3I Atlas survives the sun, then the story of humanity's solitude ends that day. For now, it remains only a point of light. No message, no movement, no declaration. Just a silent object tracing a perfect arc across the void. But sometimes silence is not the absence of meaning. Sometimes it is the prelude to it. In a universe older than fear, a fragment of something, stone, steel, or intention, is moving closer every hour. And perhaps, when the sunlight finally touches its surface, we will understand that the question was never whether we are alone. The question is whether we are ready to be seen. Chapter 2, The Arrival of 3I Atlas. It entered our solar system quietly. No blinding flash, no alarm across the observatories, no sign that anything remarkable had crossed the border between stars. Just a set of coordinates transmitted from a survey telescope in Hawaii. An object barely luminous enough to register above noise. At first it looked like debris. Perhaps a wandering comet. Perhaps a rock shaken loose from some forgotten collision. Nothing that should have mattered. But the sky does not always announce its revolutions in thunder. Sometimes it whispers them through the data. Over the following nights, the readings refused to behave. The trajectory curved with impossible grace, entering the plane of the planets at a 5-degree incline. An orientation so precise that one astronomer described it as surgical. Its speed placed it beyond capture by the sun, yet its motion suggested deliberate control. The more we tracked it, the less sense it made. A comet should scatter. This one glided. A fragment should tumble. This one balanced, steady as a gyroscope. Its light curve was wrong. Its spin period too consistent. Its surface reflectivity unnervingly uniform. The universe had introduced a contradiction and waited to see whether anyone would notice. They did. Within days, observatories from Chile to Japan had locked on. Infrared signatures showed a strange pattern, heat that pulsed instead of radiating, cycling at regular intervals, as though the object were breathing. Radio telescopes listened for emissions and heard only silence. That silence was louder than any signal. It suggested intention, or at least the discipline of something that did not wish to be heard. As the data accumulated, the models began to collapse. No combination of ice, dust, or metal could explain the observed density. Its estimated mass was too low for its momentum, its albedo too high for carbon compounds, its orbital stability too perfect for chaos. The sky had produced a riddle, wrapped in equations, and every answer led deeper into uncertainty. Scientists wrote, deleted, rewrote. Some blamed instrumentation, others blamed math. Yet the numbers kept returning like an accusation. Something was wrong, not with the measurements, but with our expectations. For the first time in decades, astronomy found itself at a crossroads between humility and fear. The last two interstellar visitors, Oumuamua and Tuai Borisov, had already stretched imagination to the breaking point. Oumuamua's acceleration, Borisov's composition, both had hinted that the universe still possessed surprises. But 3Y Atlas was different. It was not content with being strange. It was precise. Too precise. And precision, in nature, is rarely free. Sabine Hossenfelder described the feeling as intellectual vertigo. You stare at a data set, and for a moment it stares back. Each parameter aligns into meaning, then slips away again. The simplest explanation would be artificiality, yet that is the one science is least willing to accept. Her peers called her reckless for entertaining it, but she reminded them that caution and cowardice often wear the same mask. Science, she argued, must choose between protecting its pride and confronting its blind spots. Meanwhile, 3I Atlas continued its silent descent toward the sun. It passed the orbit of Jupiter, brushing through the gas giant's gravity without deviation. It slid past Mars, then Venus, moving in a plane so exact that planetary engineers joked it could guide spacecraft navigation. Each planet it ignored seemed to emphasize the one it avoided most, Earth. The geometry was elegant, almost courteous. It observed without intruding, a trajectory of curiosity, not aggression. As October 25 deepened, telescopes captured its faint tail bending in the wrong direction, curling toward the sun instead of away. Solar radiation should have pushed the debris outward. Instead, the vector suggested internal propulsion. If so, it was subtle beyond human design, constant, noiseless, and perfectly modulated. Its brightness flickered in micro-patterns, repeating every 52 minutes, like a heartbeat measured in light. Engineers ran the numbers, searching for a natural harmonic. None fit. Astronomers recalibrated, retested, rechecked. The pattern remained. A system within a system. When the European Southern Observatory released the composite images, the world finally looked up. News outlets called it the third messenger. Forums speculated about alien probes, self-replicating machines, lost civilizations. Governments remained silent. NASA issued a statement urging patience, the kind of statement that implies unease. No one wanted to say the word that hovered in every mind. Manufactured. And yet, the object itself remained indifferent to our speculation. No signal, no change in speed, no reaction to being watched. It simply moved, steady, unwavering, implacable. It behaved less like a discovery and more like a test, not of technology, but of perspective. Would humanity believe its own eyes if the universe refused to fit its categories? Avi Loeb called it poetic irony. A civilization capable of building telescopes that see galaxies a billion years old, yet paralyzed when confronted by something in its own cosmic backyard. He saw in 3-eye Atlas the continuation of a pattern, the universe offering evidence that intelligence is not confined to Earth and humanity responding with bureaucratic discomfort. He urged open study, even risk, arguing that skepticism, without curiosity, is just another superstition. But risk has fallen out of fashion. Funding agencies want certainty. Academia rewards safety. In that environment, 3AI Atlas became not a marvel, but an inconvenience. A reminder that the unknown still exists and that it refuses to fit neatly into peer-reviewed columns. It forced a question too large for spreadsheets. What if the first contact does not come in words, but in geometry? As the days shorten and the object approaches its perihelion, a quiet tension spreads across the scientific community. Some hope it will disintegrate, so the mystery can die with it. Others secretly wish it will survive, even if survival means rewriting the boundaries of physics. Every night, the light curve updates on screens around the world, each data point a heartbeat of collective anxiety. We are watching not just an object, but our own threshold for wonder. In a sense, its arrival is already complete. It has entered our equations, our debates, our dreams. It has reminded us that the cosmos is not a solved problem, but a living question. And whether it burns to vapor or endures through the sun's fire, 3-eye Atlas has achieved something no machine or myth ever has. It has made scientists feel small again. For now, it continues its perfect arc through space. A motion so precise it feels like grace, so silent it feels like judgment. The telescopes track, the data streams, the world waits. Somewhere beyond that veil of light and heat, a fragment of intention or accident keeps moving closer. And if we have learned anything from its arrival, it is this: the universe is not obliged to make sense. It is only obliged to be. Chapter 3. The Skeptic Turns Believer. For most of her life, Sabine Hossenfelder believed in limits. The kind that make the world predictable. The kind that keep wonder from slipping into delusion. To her, the universe was not mysterious, merely misunderstood. There were no gods in the equations, no cosmic intent behind the noise, only patterns waiting for precision. She was the scientist you called when a theory needed killing. Calm, logical, armed with mathematics sharper than belief. She dismantled pseudoscience for sport. Warp drives, quantum healing, multiverse fantasies, and the endless chorus of UFO enthusiasts, she cut through them all. Her lectures carried the dry certainty of someone who knew that nature, for all its beauty, was ruthlessly indifferent. And if people needed magic to make sense of that indifference, that was their weakness, not the universe's. For years, Sabine's work had a rhythm: observe, calculate, dismiss. The world loved her for it. She was science's corrective voice, a reminder that skepticism was the last true faith. But skepticism, like gravity, bends everything toward itself until it collapses under its own weight. When 3-eye Atlas entered the record, she approached it the way she always did, with numbers, its velocity, its luminosity, its strange but not impossible orbit. These were just puzzles. Every anomaly has a cause, she told herself. The task of physics is not to marvel, but to measure. And yet, As the data deepened, something in the equations refused to sit still. At first, it was the density. Calculations placed it lower than solid rock, but higher than porous ice, somewhere in the no man's land between matter and machine. Then came the light curve, oscillating with an elegance that hinted at symmetry, not chaos. Its tail, inexplicably bending toward the sun. Its orbit, aligned almost perfectly with the ecliptic. Each variable disobeyed expectation by a fraction, small enough to deny outright dismissal, large enough to gnaw at certainty. She double-checked, cross-referenced, recalibrated. Nothing changed. What she was seeing shouldn't exist, but it did. She compared notes with colleagues across observatories, expecting to find an error in the instruments. Instead, she found the same defiance written across every dataset. The universe was repeating itself, whispering the same contradiction in different languages. One night she stared at the simulation on her monitor. A pale object threading its way between planetary orbits, steady, precise, impossibly stable. It moved with the confidence of something that knew it was being watched. In that moment, her skepticism flickered, not extinguished, but briefly illuminated from within. It wasn't belief, not yet. It was the uncomfortable realization that disbelief itself might be the problem. The next morning, she wrote a line in her private notes. If intelligence leaves no signal but precision, would we even recognize it? Weeks later, that thought became the seed of her paper, dryly titled, Statistical Anomalies in the Trajectory of 3I Atlas. Buried deep within its careful language was a sentence that cracked open the consensus of her field. The possibility of non-natural origin cannot be excluded. It was not a declaration, only an allowance. But in science, allowances are dangerous. They invite questions that funding agencies do not like and headlines that scientists fear. Within hours, her inbox flooded. Some colleagues called her reckless. Others accused her of betrayal. "You're giving fuel to conspiracy theorists," one wrote. Another warned that her reputation, so carefully built on reason, would not survive association with alien talk. She didn't respond. She didn't need to. She had already crossed the line from certainty to curiosity, and there was no way back. That night, she recorded a quiet video for her YouTube channel, her tone more measured than ever. She looked straight into the camera, her voice calm, precise, almost surgical. This isn't about believing in aliens. It's about recognizing that disbelief has become a form of dogma. If we're so afraid of being wrong that we refuse to look, we're no longer doing science. We're practicing faith. The clip went viral, not because of what she said, but because of who said it. The internet labeled her the skeptic who changed her mind. Memes mocked her. Forums dissected her motives. But beneath the noise, something else stirred. Respect. The kind reserved for those who question even their own convictions. In academic circles, however, respect is a currency that devalues quickly. Invitations to conferences dwindled. Collaborators grew cautious. Some journals refused to review her paper. She had become what she once despised, a scientist on the fringe. And yet, she felt lighter than she had in years. For the first time, she wasn't defending certainty. She was defending curiosity. As 3I Atlas drew closer to the sun, the data grew sharper, crueler. Spectroscopic analysis revealed metallic emissions inconsistent with natural bodies, traces of nickel, iron, and something else no one could quite categorize. Thermal readings suggested a persistent internal heat source, cycling rhythmically, as though powered by intent rather than sunlight. Sabine read the reports in silence. Each new result felt like another step toward an edge she didn't know existed. She had spent a lifetime teaching others that the universe doesn't care what we hope is true. But what if indifference and intelligence could look the same from a distance? Her colleagues argued on live stream panels. It's just a comet. The math is incomplete. Statistical outlier. But every dismissal sounded rehearsed. They were not debating 3i Atlas anymore. They were defending their right not to be astonished. When journalists asked her what she believed now, she gave the same answer every time. Belief isn't the issue. Observation is. I don't know what it is, but it's not behaving like it should. That's enough reason to pay attention. That restraint, precise, cold, fearless, was what made her dangerous. She refused to fill the silence with speculation, and that silence became the loudest voice in the room. By mid-October, the object had entered the inner solar system. Ground-based telescopes captured its tail, shimmering against the solar wind, bending inward like an act of defiance. The closer it came, the more it seemed to rewrite what a comet was supposed to be. The public called it the visitor. Scientists called it the problem. Sabine called it the mirror. Because, as she explained in one of her lectures, 3i Atlas wasn't just challenging the laws of physics, it was exposing the psychology of science itself. Every profession builds walls around its comfort zone. Physics builds them out of math. But even the strongest equations can't protect against what they refuse to see. She told her students, half in jest, if this thing turns out to be artificial, it won't just change physics, it'll change psychology. Because we'll have to admit that the first proof of intelligence beyond Earth didn't come from a message, but from our own arrogance being wrong. The room laughed. She didn't. Late one night, while reviewing data from the European Southern Observatory, she caught a reflection on her screen, a faint curve of light traced against the void. It was nothing, probably a glitch, but it made her pause. For a fleeting moment, she thought of the ancient astronomers who had mistaken comets for omens, angels, or divine messengers. Maybe they weren't wrong. Maybe they just lacked vocabulary. Science, she realized, is still doing the same thing, translating mystery into language we can survive. She closed her laptop, the glow of the monitor fading into darkness, and whispered to no one in particular, whatever it is, it's beautiful. That was her heresy. Not belief, not surrender, but wonder. And in the silence that followed, she understood the paradox she had spent her life denying, that doubt is not the enemy of science. It is its beginning. The skeptic had become the believer, not in aliens or miracles or fantasies of cosmic salvation, but in the one thing she had spent a lifetime forgetting, that the unknown still matters. 3i Atlas did not need to send a signal. Its existence was the signal. And for the first time, Sabine Hossenfelder, the scientist who built her name on certainty, looked up at the night sky and felt something she hadn't felt in years. Not fear, not faith, just humility. Because sometimes the universe doesn't need to prove us wrong. It only needs to remind us that we never had it all right. Chapter 4. The Impossible Data. The deeper humanity looked into the numbers, the more impossible they became. 3i Atlas was supposed to be a comet, a wanderer of ice and rock carried from the cold between stars. It was supposed to evaporate predictably under the sun's heat, to brighten, to fracture, to die. But it didn't. Instead, it began to rewrite the grammar of physics one measurement at a time. The spectrographs were the first to betray us. When the European Southern Observatory released the early data, everyone expected to see the usual fingerprints of cometary chemistry: frozen water, carbon monoxide, dust grains. What appeared instead was an emission pattern that belonged nowhere in the catalogs. Bands of nickel and iron showing with an intensity that required internal heat far beyond solar radiation. These metals do not simply evaporate in space. They must be refined, melted, forged. To anyone trained in astrophysics, the signal read like a confession. Something inside 3I. Atlas was running hot when it should have been frozen. Teams in Chile, Arizona, and the Canary Islands ran the numbers again, hoping for error margins, hoping for noise. The readings persisted. Every night the same improbable glow, every calibration confirming it. It was as if the object were keeping itself alive. Then won't the gas ratios. Instruments recorded a carbon dioxide to water vapor proportion nearly 8-to-1, an inversion of the natural hierarchy. In known comets, water always dominates, a remnant of primordial ice. Here, CO2 reigned, the signature of combustion, not sublimation. It was an atmosphere made by reaction, not by chance. Some suggested exotic chemistry from a foreign star system. Others whispered the word no one wanted to print: exhaust. But if there was propulsion, it was too subtle for our mathematics to catch. The acceleration remained microscopic, the trajectory perfect, immune to gravity's gentle pull. It did not drift. It corrected. The anomaly deepened when polarization studies began. Light reflected from the surface of 3I Atlas was polarized in a way inconsistent with dust or ice. It was smooth, almost mirrored, as though the sunlight skimmed across a uniform lattice instead of scattering from irregular grains. That could only mean one of two things. Either its surface was composed of materials unknown to chemistry, or it had been shaped. The equations offered no third option. Astronomers adjusted for every variable: angle, rotation, distance. The numbers held. Every reflection whispered of design. But nature, they insisted, does not design. It only emerges. Still, emergence had never looked so deliberate. As data flowed across servers in Boston, Geneva, and Tokyo, something strange began to happen among the scientists themselves. Their language changed. Phrases like the object or the body gave way to the visitor. Some began capitalizing it, as if unconsciously promoting it from noun to proper name. They stopped referring to it as an it. They said he, she, or most often, they. A linguistic contagion spreading through emails and notes, an acknowledgement that precision was no longer enough to contain what they were describing. The datasets grew denser, like sedimentary layers of disbelief. Thermal imaging revealed a periodic fluctuation in surface temperature, an exact 52.3-minute cycle, stable to the second, repeating day after day. It was not random. Nothing in space is that precise unless it is measured against something internal. Theories multiplied. rotational resonance, venting pattern, oscillating jet. But each would have left visible debris or deviation. There was none. The thermal wave simply pulsed, constant, silent, perfect. The simplest model to fit the data was not natural at all. It was mechanical. Sabine Hossenfelder read the results with a kind of clinical despair. Every new parameter carved deeper into the wound of probability. She could explain noise, calibration drift, even systemic bias. But not this. She told her students that science was built on the principle that the universe cannot lie. And yet, for the first time, she wondered if truth itself might be beyond statistical reach. In a later interview, she would recall, "It felt like staring into a mirror that refused to show your reflection. You realize the equations work. They just don't work for you anymore." Around the world, the data kept converging. The Hubble Space Telescope captured microflares, brief surges of luminosity from the leading edge of the object, faint but rhythmic, like a heartbeat written in photons. The intervals matched the thermal cycles almost exactly. Heat, light, motion, 3 signals pulsing in harmony. It was either coincidence stacked upon coincidence or choreography. If the universe was trying to tell a story, it was writing it in repetition. At NASA's Jet Propulsion Laboratory, analysts proposed a desperate alternative. Perhaps 3. Atlas was hollow, its core filled with cavities that created resonance effects, tricking instruments into reading precision where there was chaos. The math didn't support it. The probability of such a configuration forming naturally was smaller than the probability of intelligent design itself. But probabilities are only numbers until they threaten what we believe. So the debate turned philosophical. How much evidence does it take for the unbelievable to become merely improbable? And at what point does improbability become denial? 3I Atlas was forcing scientists to quantify faith in reverse. Meanwhile, the public had already decided. Online forums called it a ship, a scout, a harbinger. Every frame from telescopes became digital scripture. Every pixel dissected for meaning. Government agencies denied everything and confirmed nothing. A silence that sounded almost coordinated. Conspiracy grew where uncertainty lived. For the first time in generations, physics had become mythology again. It was beautiful and terrifying in equal measure. Through it all, 3I Atlas remained impassive, gliding through our equations with the stillness of something that had already seen the outcome. Its trajectory curved like handwriting, elegant, effortless, self-assured. The closer it came to the sun, the brighter it burned, but never enough to suggest disintegration. Natural objects suffer under heat. This one seemed to thrive in it. The solar radiation that should have stripped its surface instead scattered evenly, reflecting without the chaotic sparkle of dust. The albedo curve and its brightness factor stayed flat, stable, controlled. It was, by every metric, disobeying thermodynamics with quiet dignity. At Mission Control in Pasadena, a physicist muttered, "It's not just surviving the heat, it's using it." No one replied. There are moments in science when silence is the only appropriate peer review. And so the data kept coming. Beautiful and merciless, demanding interpretation, yet offering none. The closer the measurements came to truth, the less that truth resembled anything familiar. The magnetometer readings taken from orbital satellites showed minute disturbances trailing behind the object, ripples of electromagnetic interference that echoed in the solar wind like the wake of a submerged engine. The pattern was faint, but ordered, a repeating waveform at precisely 0.78 Hz. No natural plasma fluctuation in recorded history has ever held a steady frequency across millions of kilometers. Yet there it was, steady, silent, repeating, a hum written into the void. When technicians filtered the noise, they discovered harmonic overtones nested inside the signal, fractal and recursive, each octave containing a trace of the next. Some called it resonance, others information. No one called it coincidence. Theories multiplied like cells dividing in panic. Some proposed crystalline dust rotating in synchronized clusters. Others invoked quantum interference between light and metal. But every attempt to normalize the impossible only made it stranger. The signal wasn't strong enough to be communication, yet it was too precise to be chaos. Whatever it was, it existed halfway between physics and intention. The more instruments we built to understand it, the more it seemed to anticipate our scrutiny, adjusting just enough to remain ambiguous. Observatories on 3 continents compared timestamps and found that when one array turned toward it, another detected a fractional dip in brightness, as if the object sensed attention. The numbers were small, the effect statistically negligible, but the timing was perfect. Probability failed where coincidence began to mimic awareness. In Geneva, a small group of data analysts began calling the phenomenon the reflex. They didn't mean it metaphorically. They meant it behaved like something with nerves, yet no one dared use the word alive. Instead, they filled reports with neutral phrases, dynamic feedback, nonlinear coupling, reactive coherence. Language folding itself into armor. Sabine Hossenfelder watched these reports accumulate like sediment. Each paper arrived with the same tone of a cautious disbelief, the same ritual disclaimers that the anomalies do not imply agency. But she could feel the fear between the lines, the fear not of being wrong, but of being first. She had seen that fear before. In particle physics, when the equations hinted at truths the instruments weren't ready to confirm. She knew the pattern: ridicule first, silence second, acceptance last. The difference was that 3i Atlas wasn't a theory. It was there, luminous, undeniable, daring the world to decide what it believed. By mid-October, the solar observatories began detecting something unprecedented. A faint bow shock preceding the object, the kind produced by a magnetic field interacting with charged particles. Comets can generate fields through ionization, but never this organized, never this stable. The geometry was beautiful. A thin halo shaped like an electromagnetic shield. It pulsed faintly in sync with the 52-minute thermal cycle, as if the object exhaled energy into the void and gathered it back again. The data was irrefutable. Something aboard 3i Atlas, if aboard could even apply, was managing energy. That single implication split the scientific community like tectonic plates. One camp clung to naturalism, constructing increasingly elaborate models of mineral composition and electrochemical feedback. The other whispered that they were describing a machine. The argument became theological in everything but name. One side defended order, the other confronted wonder, and both were terrified of what belief would cost them. Journalists swarmed, Headlines bloated. Governments retreated behind policy statements that promised continued observation. And still, the object sailed on, serenely indifferent to the noise of its observers. Every fresh data set was another confession of ignorance. The object's surface temperature, instead of climbing toward meltdown, began to oscillate between extremes, cooling sharply before each heat surge, a thermal heartbeat that implied control loops. Engineers at ESA compared it to a spacecraft performing adaptive shielding. NASA called it radiative self-regulation. The public called it impossible. Sabine stopped correcting them. She had crossed the invisible threshold where semantics cease to matter. What mattered was humility before data. One evening, she was invited to a closed-door panel with representatives from ESA, NASA, and the German Aerospace Center. The discussion was polite until someone asked the unaskable question: if it is artificial, what should we do? No one answered for a long time. Finally, Sabine said, almost to herself, "Observe. Nothing else makes sense." That phrase, recorded off mic, half swallowed by static, was later quoted everywhere. Observe. Nothing else makes sense. It became both mantra and defense, the only rational position left when knowledge outpaces comprehension. Yet even observation was becoming a paradox. The closer 3I Atlas came, the less light it gave off in visible wavelengths. Instruments registered the same luminosity in infrared, the same heat, but the optical brightness dropped. It was as though the object were dimming itself selectively, hiding from human eyes while remaining brilliant to machines. The spectra flattened, colors drained, the visual curve collapsing into a monotone band. "It's turning invisible," someone whispered. But invisibility was the wrong word. It wasn't vanishing. It was adapting. Light was not being lost. It was being redirected. The equations described a kind of controlled absorption, a manipulation of albedo that no known material could achieve. If this was coincidence, it was the most polite coincidence in history, adjusting itself only in the wavelengths humans could see. The gesture felt deliberate, almost considerate. A silent acknowledgement that we were watching and that it preferred to remain unseen. By the third week of October, the phrase "impossible data" had entered every internal memo. It no longer referred to any single anomaly, but to the collective weight of them all. The way every experiment designed to prove 3I Atlas ordinary ended by proving it exceptional. Patterns of impossible precision, heat without decay, motion without inertia, silence without randomness, each contradiction a thread in a tapestry too consistent to dismiss. The object was no longer just defying models, it was writing new ones. Sabine described the feeling as standing on the shore of reason, watching the tide pull knowledge out to sea. For every variable pinned down, two new uncertainties emerged. She began to suspect that the data itself was not failing us, that it was succeeding. But we were the ones out of calibration. Perhaps the universe was not misbehaving. Perhaps measurement was an act too primitive for what it was revealing. When a student asked her whether she still believed 3I Atlas might be natural, she smiled, not kindly, but honestly, and said, "Natural is a definition we built to make ourselves comfortable." The student didn't know how to respond. Neither did she. Outside, the world was counting days to perihelion, the moment when truth would pass closest to fire. Inside laboratories, the servers hummed like prayer wheels, converting mystery into data, data into awe. Humanity had entered the age of impossible precision, and somewhere in the numbers, something was waiting to be understood. Chapter 5: The Price of Caution. In science, every question is a wager against uncertainty, and every answer carries a cost. The cost is measured not in money but in error. Two kinds define the boundary of human understanding: Type 1 and Type 2. The first is believing something that is not true. The second is failing to believe something that is. The entire history of reason can be mapped as a pendulum between these mistakes. For centuries, science has built its authority on the avoidance of Type 1 error, on never being wrong. Every peer review, every statistical threshold, every cautious phrasing in a research paper exists to protect against false positives. It is the armor of skepticism, forged through centuries of embarrassment and fraud. But armor has weight, and weight slows movement. Somewhere along the way, that protection became paralysis. To avoid being wrong, science learned to stop being bold. That is the price of caution. Sabine Hossenfelder understood this better than most. She had spent half her life enforcing that caution, teaching young physicists that extraordinary claims require extraordinary evidence. It was a good rule until the extraordinary stopped caring about evidence. When the data from 3i Atlas arrived, clean, verified, repeatable, it fit none of the categories that caution had built. Every measurement whispered the same unthinkable pattern, and yet the reflex of denial was automatic. "We cannot say that," she heard again and again in meetings. "It will sound unscientific." But what is unscientific about observation? What sin lies in admitting that the universe has outgrown our definitions? She began to see that the obsession with avoiding Type 1 error, believing what isn't real, had blinded the community to its twin sin, rejecting what is. Type 2 error, the failure to recognize truth, the safer mistake, the respectable mistake, the one history forgives because it leaves no proof behind. No scientist is remembered for the truth they refused to see. That error leaves no headlines, only silence. And silence, Sabine thought, is the most elegant form of denial. 3i Atlas was the perfect test of this equation. If it was natural, declaring it artificial would be a false positive, a Type 1 error, the great humiliation of science. But if it was artificial and we dismissed it as natural, that would be a false negative, a Type 2 error, the greater tragedy. In the balance between pride and discovery, humanity always chooses pride. It is safer to mock the extraordinary than to face it. Safer to call wonder pseudoscience than to risk the embarrassment of awe. She wrote once in her notes, never published, "We fear being wrong more than we desire to be right." It was not cynicism. It was diagnosis. In her private reflections, she began to trace the history of this fear. Galileo's heresy, Newton's mysticism, Einstein's ridicule, quantum theory's rejection. Each revolution began as a mistake in the eyes of its time. Each was a Type accusation turned Type 2 revelation. The difference between genius and delusion was never data, it was patience. But modern science had lost patience. It had become industrial, bureaucratic, allergic to risk. It demanded certainty from a universe that had never promised it. And so, when faced with 3i Atlas, the machine of skepticism did what it was designed to do. It denied. Committees wrote guidelines on terminology, insisting the word artifact not appear in official communications. Press releases were stripped of adjectives. The object became anomalous, never intelligent. Every cautious edit was a small victory for safety and a small defeat for curiosity. Sabine could almost hear the pendulum swing. For decades it had protected truth from fantasy. Now it protected comfort from truth. She understood the irony. By worshiping evidence, science had begun to fear discovery. Because discovery is messy, ambiguous, and therefore reputationally dangerous, the truth may exist, but not every truth is publishable. And so, in laboratories around the world, the raw data of 3E Atlas was quietly reframed until it resembled something the journals could accept. The precision was called anomaly. The synchronization was called coincidence. The impossible became inconvenient, and the inconvenient became noise. This was not conspiracy, it was instinct, the instinct to survive within the system that rewards certainty. A Type 2 culture born from centuries of Type 1 fear. When asked by a journalist why she seemed less concerned with being wrong than her peers, Sabine answered, "Because being right isn't always safe either." The quote spread online, detached from its context, turned into a meme. But she meant every word. Safety is the slowest form of extinction. A civilization can collapse, not from false belief, but from disbelief so strong it refuses to see what stands before it. In the end, the difference between the two errors is philosophical. Type 1 is punished by embarrassment. Type 2 is punished by history. One ruins a career, the other ruins a species. And faced with 3i Atlas, humanity was quietly choosing which punishment it preferred. The agencies decided on neutrality: observe, record, refrain from conclusions. It sounded noble, but Sabine recognized it for what it was: paralysis disguised as professionalism. Observe was the last refuge of the frightened rational mind, a word that means wait until the mystery goes away. But this mystery did not go away. It grew brighter, sharper, more articulate in its defiance of our models. The longer we observed, the less we understood, until understanding itself became an act of risk. That was the paradox of 3i Atlas. It forced science to face its own superstition. The superstition that caution equals truth, that humility means silence. But humility, Sabine realized, was not silence. It was courage without arrogance, the willingness to say, "I do not know, but I am still looking." That, she thought, is what science was supposed to mean. Somewhere in the void, the object kept moving, as patient as eternity, waiting for its observers to decide which error they were willing to make. And in that waiting, the real experiment was revealed. Not the study of an interstellar visitor, but the study of human certainty itself. Chapter 6: Avi Loeb's Vindication. For years, Avi Loeb was the heretic of modern astronomy. the professor who dared to ask whether the universe might already have noticed us. His peers called him reckless, sometimes even dangerous, not because he was wrong, but because he was willing to be right too soon. In a discipline where reputation is preserved through consensus, he spoke of civilization in cosmic terms, of technology as archaeology written in the sky. When Oumuamua appeared in 2017, a sliver of light moving too fast and too precisely to be dismissed as random debris, Loeb suggested the unthinkable, that it might have been an artifact. The reaction was immediate and merciless. Colleagues rolled their eyes, journalists called him eccentric, committees withdrew funding. It was not the data that condemned him, but the audacity of interpretation. In a world that worships the measurable, imagination is the last forbidden experiment. Yet Loeb never retracted. He said simply, "If it walks like a duck and quacks like a duck, we should at least check whether it's a duck." It was a scientist's way of saying, faith and evidence are not enemies, only sequential steps in curiosity. When 3Y Atlas arrived, the echo of that old controversy came rushing back. The same denials, the same discomfort, but this time, the data refused to yield to dismissal. The object's precision was not anecdotal, it was statistical. Its stability was not poetic, it was measurable. And with every new anomaly confirmed, the distance between Loeb's heresy and orthodoxy shrank. He didn't gloat, he didn't need to. Reality was doing it for him. He wrote an essay titled "Vindication is a Poor Reward," where he said, the point was never to be right. It was to make room for the possibility that the universe is more interesting than we are brave. That line became prophecy. In Cambridge, the Galileo Project, a small initiative he founded to search for physical evidence of extraterrestrial technology, suddenly transformed from curiosity to crucible. Donations poured in. Former skeptics offered collaboration. Even those who had mocked him began citing his work cautiously, the academic equivalent of apology. But Loeb didn't celebrate. He had seen how quickly vindication turns to fear. To be right in science is one thing. To be right about the existence of something smarter than us is another. It is not triumph. It is exposure. He told a student during an interview, the real question is not whether they exist, but whether we want them to. That sentence haunted readers because it inverted the myth of discovery. Humanity had always imagined first contact as revelation, not judgment. But what if discovery is a mirror? And what we find there is our own immaturity. The Galileo Project became the front line of that mirror. Loeb's team assembled instruments across the globe, wide-field telescopes, radar arrays, AI filters trained to detect anomalies in motion. The goal was simple: capture evidence, any evidence, that technology beyond Earth could leave a measurable trace. The first months yielded nothing except ridicule. But after, 3Y Atlas entered the inner system. Their sensors began recording data they couldn't explain: infrared bursts, radio shadows, polarization spikes. Every pattern matched the impossible observations reported by space agencies. For the first time since his exile from mainstream respectability, Loeb's methods were not dismissed. They were studied. He began receiving quiet invitations to closed conferences, the same rooms that once barred his entry. He accepted, though not out of pride. He understood the irony, that only after the sky screamed did the deaf remember how to listen. He was fond of quoting the dark forest theory from Liu Cixin's novels, the idea that the universe is a vast forest where every civilization is both hunter and prey. The logical strategy, therefore, is silence. Hide your light, avoid detection, survive. Loeb had long argued that perhaps the reason the cosmos seems empty is because it is polite. Civilizations that announce themselves are eliminated by those that do not. It was an elegant metaphor until 3Y Atlas appeared. Then it became something closer to instruction. If the object was observing us, it was doing so exactly as a hunter would, quietly, efficiently, without revealing position or purpose. Its silence was not emptiness. It was discipline. To Loeb, this was the true horror of the dark forest. Not that it implies danger, but that it implies etiquette. Intelligence that knows how not to be seen is intelligence that has learned fear. And fear, he said, is the most universal law of life. When reporters asked if he thought 3I Atlas was a mothership, he smiled without humor. Every civilization is a mothership, he replied. The question is only whose children we are. The term mothership spread through the media like infection, catchy, simplistic, irresistible. It reduced his careful reasoning to spectacle. But Loeb didn't correct it. He understood that language is gravity. Words pull ideas into orbit until they find stability. If calling it a mothership was what it took for the public to look up, then so be it. He knew that wonder was the rarest natural resource of all. What mattered was not belief, but attention. Attention is how civilization learns. In his lectures, he often said, "Discovery begins with permission. Permission to see, to doubt, to ask. Permission to be wrong without fear." It was that philosophy, more than any telescope, that made the Galileo project dangerous, because it invited the world to imagine again, and imagination, once awakened, cannot be put back into theory. 3I Atlas had not only revived Loeb's career, it had vindicated his principle that the extraordinary deserves investigation, not suppression. He argued that skepticism had become ritual rather than reason, a firewall against embarrassment rather than ignorance. If the truth threatens your credentials, he told a symposium, then it's not truth that's fragile. Some applauded, others left the room. But none could deny that his confidence had aged into accuracy. For the first time, the universe seemed to be speaking in his language. Metallic light, deliberate silence, impossible precision. To everyone else, it was chaos. To him, it was syntax. As the days toward perihelion dwindled, Loeb found himself at the center of a conversation he never wanted to win. Every news outlet that once mocked him now begged for interviews. Governments requested private briefings. Investors asked how they could monetize discovery. He refused most of them. Vindication had become noise, and noise was the last thing he wanted near signal. The Galileo Project's observatories in New Mexico and Hawaii were streaming constant data, terabytes per hour, and the readings were beyond beautiful. They were cruel. The object was changing. Its albedo began fluctuating in sequences, precise intervals of brightness and shadow that repeated with mathematical rhythm. It was as if the thing were communicating, but in a language of geometry, not words. Loeb didn't call it a message. He called it behavior. He told his team, "We're not observing a comet. We're observing an intention." The statement leaked, igniting a new storm of speculation. Some accused him of sensationalism, others of prophecy. But those who had read his earlier work understood that he wasn't guessing, he was interpreting. To him, data was never just numbers, it was personality written in mathematics. The rhythm of light, the harmony of movement, the composure of something that refuses to panic, even under the gaze of a species desperate to understand it. If there is intelligence in the universe, he once wrote, it will reveal itself not through conversation, but through consistency. For years he had been called arrogant for saying humanity was not exceptional. Now, as the impossible data of 3I Atlas unfolded, arrogance seemed to belong entirely to those who insisted we must be alone. He often cited the paradox that civilization teaches humility through humiliation. The same community that once banished him was now borrowing his language. Phrases like techno-signature and extraterrestrial artifact appeared in official documents with no attribution. He didn't care. He said the words were public property now. What mattered was that they were being spoken aloud without laughter. That, to him, was progress. In late October, Loeb gave a lecture at Harvard titled "The Discipline of Wonder." It was less a talk than a quiet confession. He spoke about the scientific method as a moral act, not merely an intellectual one. The discipline to accept uncertainty without turning it into fear. The universe is not a lab, he said. It's a conversation. The problem is that we only listen when it flatters us. He paused, scanning the silent audience. 3I Atlas is not a miracle. It's a reply. The line echoed online for weeks. Some praised its poetry, others condemned its arrogance. But beneath both reactions lay the same truth. For the first time in generations, people were thinking about science as a dialogue rather than a doctrine. That was Loeb's quiet victory. The concept of the dark forest returned often in his interviews. He explained that perhaps the reason we are being observed is not curiosity, but caution. That whoever sent 3I Atlas, if it was sent at all, is governed by the same terror that defines all intelligent life, the terror of discovery. In that framework, silence is survival. Light is confession. We imagine that communication is benevolent, he said, but maybe communication is surrender. He wondered aloud if Earth's radio emissions, our noisy declarations of existence, had already betrayed us centuries ago. The thought disturbed listeners, not because it was dark, but because it was logical. Loeb had no interest in fear-mongering. To him, fear was just data in emotional form. What mattered was preparation, not military, but psychological. The first step to meeting another civilization, he said, is to stop acting like we deserve to. He believed that intelligence, wherever it exists, evolves toward modesty. The more a species understands, the less it needs to announce itself. That is why, he said, the universe looks empty. Not because there's no one there, but because the wise have learned to be quiet. 3I Atlas, then, was not proof of other life. It was proof that humility can travel faster than light. As his reputation transformed, so did the tone of his colleagues. Many began to reinterpret their earlier positions as strategic skepticism, claiming they had always been open-minded. Loeb did not correct them. He knew science advances not by apology, but by amnesia. What yesterday was heresy becomes today's consensus once the evidence grows too loud to ignore. His vindication was not personal. It was structural. It revealed that the system itself had a latency, a speed of acceptance slower than truth's velocity. That gap, he warned, is where civilizations stagnate. The real danger, he wrote, is not ignorance. It's delay. In one essay, he described 3E Atlas as a test of planetary maturity. If we treat it as miracle, we regress. If we treat it as enemy, we panic. Only if we treat it as data do we evolve. He compared the moment to the Renaissance, the rediscovery of humility after centuries of certainty. The universe, he said, was giving us a second Renaissance, one written not in art and scripture, but in mathematics and silence. When asked what he would say to those who still refused to consider extraterrestrial intelligence plausible, he answered with the smallest of smiles. They remind me of the fish who refused to believe in the ocean. As perihelion approached, Loeb spent long nights at the Galileo Project's control room, surrounded by screens that translated light into meaning. He said it felt like watching history being written in binary. The object was passing between Mercury and the Sun now, the region of space where instruments strain against radiation. Yet 3Y Atlas continued to broadcast its silent precision. Its trajectory adjusted by microdegrees, always correcting, always aware. The data curve was perfect, too perfect. Loeb stared at it and whispered, "It's flying through equations." When his assistant asked what he meant, he said, "It's following laws we haven't discovered yet." He wasn't being poetic. He meant it literally. Every variable fit into a pattern that mathematics could describe but not explain. It was as though the object had been designed by a civilization that built science from different axioms, one where the boundaries between physics and intention were thinner. The thought didn't frighten him. It exhilarated him. He said later that 3I Atlas was the closest he had ever come to witnessing beauty in its purest form, order without arrogance. Chapter 7, Countdown to Perihelion. The final 13 hours unfolded like the slow inhalation of the universe itself. Around the world, observatories stayed awake beneath sleepless skies, watching the numbers crawl towards zero. The data streams were silent symphonies, columns of figures, graphs of light curves, telemetry translating mystery into digits. Somewhere between those digits, meaning hid like a ghost between radio waves. 3I Atlas was now less than 20 million kilometers from the Sun, moving at a velocity that made human comprehension useless. At that speed, distance became philosophy, not physics. It no longer orbited, it approached. The solar wind battered it with radiation strong enough to vaporize iron, yet the object held its trajectory with surgical precision. No tail formed, no dust shed, no signal broke. It was as though the Sun itself had agreed not to interfere. The European Solar Orbiter sent back a final image, grainy, overexposed, but unmistakable. A small ellipse of metallic light, sharper than it should have been, cutting through the corona like a thought through flame. And then, without ceremony, it entered the region where no instrument could follow. For minutes, there was nothing. Silence expanded across the networks like a second cosmos. In control rooms from Pasadena to Tokyo, scientists stared at blank telemetry screens, their faces illuminated by absence. They had spent months measuring an anomaly, and now the anomaly had become a void. The universe was holding its breath, and so were they. Sabine Hossenfelder stood beside a console in Munich, her reflection fractured in the glass as data lines flickered and died. For the first time in her life, she felt the precise weight of ignorance, not as failure, but as awe. The numbers had run out of room to describe reality. They had reached the edge of mathematics, and beyond it waited only metaphor. She whispered to no one. If it survives, the story changes. If it doesn't, the story still changes. Across the ocean, Avi Loeb watched from the Galileo Project's headquarters, eyes fixed on a monitor that showed nothing but noise. He smiled faintly. Perihelion is confession, he murmured. To him, this was not loss. It was punctuation. Every disappearance is an answer phrased as silence. He knew that whatever emerged, dust or signal, absence or design, the universe had already spoken in the language of precision. The team around him waited for updates, their whispers brittle with anticipation. Minutes became hours. Time stretched until it felt like a physical pressure, an atmosphere of waiting so dense it could bend thought. Somewhere in that waiting, belief and doubt began to dissolve into the same emotion. When the instruments came back online, the first readings arrived not as light, but as absence of expected light. The region around the sun's southern hemisphere, where 3I Atlas should have reemerged, showed a deficit, an unnatural shadow, circular and faint, moving counter to the solar rotation. The analysts called it an artifact of data compression. Loeb said softly, "It's still there." He had no evidence, only intuition, but intuition has always been the first language of discovery. Hours later, as the solar glare eased and the magnetic interference thinned, a new signal appeared, faint, coherent, repeating. Not in radio, not in light, but in polarization, a pattern in how photons aligned as they escaped the sun's gravity. The signal was subtle, woven into the chaos like a signature too elegant for brute translation. It repeated exactly every 52 minutes and 20 seconds, the same rhythm that had haunted the data since the object first appeared. The cycle had survived the sun. Sabine saw the numbers appear on her monitor and closed her eyes. Somewhere, the equations she had spent her life defending were quietly rewriting themselves. The object had not perished. It had adapted, its luminosity flattened, its temperature stabilized, its trajectory corrected by fractions too small for natural drift. Whatever 3I Atlas was, it was still functioning. The scientists tried to call it coincidence, but the word tasted obsolete. In press briefings, agencies used phrases like radiative equilibrium and dynamic shielding. They pretended the extraordinary could still fit inside the vocabulary of reason. But language was falling behind light. The truth was simpler and more unbearable. Something had gone into the fire and come out whole. The world reacted the way it always does to revelation, with distraction. Markets dipped, media theorized, governments met in silence. The internet became a cathedral of speculation, each theory a prayer, each rumor a new form of disbelief. For every headline declaring survival, another demanded decay. But no one could erase the data. The pattern was real. The universe had kept time with us. In those days after perihelion, Loeb refused interviews. He said there was nothing left to say until the object left the inner system. "You don't speak during an eclipse," he told a reporter. "You wait for light to decide whether it's coming back." Sabine, too, grew silent. She no longer argued, no longer corrected anyone. She wrote in her journal that the difference between knowledge and faith was duration, how long one could endure not knowing. And the world endured. Each night the telescopes searched for the returning light, and each night the silence between data points grew heavier. It was no longer fear, it was reverence. 3I Atlas had passed through the sun, the furnace that defines mortality, and in doing so, it had become myth. Whether it was machine or miracle no longer mattered. What mattered was that it had survived a question no human could have answered. The countdown was over. The waiting had become history. What if she's right? What if Sabine's quiet defiance was not arrogance, but prophecy? What if the real error was never in the data, but in our refusal to feel small again? Because in the end, 3I Atlas is not the story of an object. It is the story of us. The only species that builds telescopes to look outward and walls to look away. We demanded the universe reveal its truth, and when it did, we called it anomaly. We begged for a sign, and when it came, we labeled it noise. Perhaps that is the truest psalm definition of civilization. The art of explaining wonder until it stops being frightening. Sabine Hossenfelder once said that science is not about certainty, but endurance. The ability to stand before the unknown and keep looking. She never asked anyone to believe. She only asked that we not be afraid of being wrong. Yet the question she left behind burns brighter than any star. What if the universe has been speaking all along, and we were simply too proud to listen? If she's right, then everything changes. Not because aliens exist, but because humility does. The discovery would not diminish us. It would define us. For the first time, humanity would be forced to see itself as part of a continuum, not a crown. We would have to confront the unbearable truth that intelligence is not the summit of evolution, but just another form of survival. And survival, as the cosmos keeps reminding us, is temporary. The lesson of 3I Atlas is not about visitors or probes. It is about perspective. It asks whether we can evolve intellectually without collapsing emotionally, whether we can hold two truths in the same mind, that we are significant enough to be noticed and insignificant enough to be studied. It asks whether our faith in reason can coexist with the vastness that reason cannot contain. In a world addicted to certainty, her courage was an act of rebellion. She didn't offer answers, she offered the permission to ask. And that, perhaps, is what the universe has always demanded of us, not belief, not obedience, but attention. Maybe 3I Atlas was never proof of intelligence beyond Earth. Maybe it was a mirror, showing us what intelligence on Earth looks like when it forgets how to wonder. We have built machines that see further than our imagination. But imagination remains the only instrument capable of revelation. What if the next question isn't, what is it, but what will we become once we know? The countdown is over. The fire has passed. The data will keep whispering its impossible song long after we stop listening. But somewhere between those numbers, something has changed. The silence no longer feels empty. It feels expectant. And if you have watched this far, you already understand that change begins not with discovery, but with attention. Maybe that's why you're here. To listen differently, to wonder again, to ask quietly, what if she's right? If the story of Three-Eye Atlas has taught us anything, it's that the universe is not waiting for us to believe. It's waiting for us to notice. So stay curious, stay skeptical, but never afraid. Because the moment we stop asking, the silence wins. And somewhere out there, in the long mathematics of the stars, something patient is still watching, still waiting for us to finally look up.